Let's go through this really quickly. For those of you that missed it, we had a tutorial review for the test. I have put it up on the YouTube. Make sure you've picked up, if you weren't here, make sure you picked up both review papers. I have put the review papers up online on Canvas, so if you want to print them out and try them again after having done them once, you can. We are going to do the lab today, classification of chemical reactions. You do need to have the pre-lab done before you go back. It is an individual lab, so we'll need to make sure we do what we need to do back there. Okay.
So is there going to be another review day?
Yes, Wednesday after school. So if we look really quickly at the lab. So if you look at the lab here with me really quickly, I am going to do the combination A with you because we're back in the very back lab, so we do not have access to the Bunsen burners. Yes?
Will you be here after school, if like a few minutes after school, if we don't finish the lab?
Yes, but everybody's been finishing the lab easily and had 30 to 45 minutes to finish.
45 minutes or left?
Left
Oh, okay.
to finish it up in here, finish writing it up.
Okay.
Yes?
So for part A and B of signal replacement reactions, are we going to do those like as soon as we get done?
Yes. We're going to talk about that. Okay, so I am going to do this magnesium ribbon with you. You're going to do the hydrochloric acid and ammonium hydroxide. This part right here, please listen. This part B, is in the hood in the back. So it's in the back hood. Okay, you'll need to do this part with a partner. It makes it a lot easier because you've got to do the drops of the hydrochloric acid and the drops of the ammonium hydroxide about the same time and then put them next to each other. If you wait and do one and then the other, then they vaporize and it doesn't react as fast or nice. Yes?
For the A decomposition reaction, are you going to do that one?
Let me get there. Okay, so when it comes to the decomposition reaction, on the first one, potassium perchlorate, I'm going to demonstrate that in the fume hood right after I do that part A of the combination one. You get to do the hydrogen peroxide one, and I'll show you how to do the glowing splint thing with the potassium perchlorate one, so that when you do it, you're going to do it in the back. I'm going to have a candle that's lit that you can light your wooden splints with in the back, that then you can blow them out and put them in. Okay, on the single replacement reactions, both of these, put a star by them. You need to start these first. So the minute you get back in lab, you want to start your silver nitrate and your copper nitrate solutions right away because these you have to look at every 5 minutes. So it'll take a minute to do that. Make sure you guys pick up the review sheets. Okay, on the last one here, the double replacement reaction, on number 4 right here, it says sodium chloride. It should have said sodium nitrate. When I copied and pasted, I did not fix that. Okay, so the NaNO3 was correct, but this right here says chloride, and it should have said nitrate. Okay, on these two right here, when you're done with them, there is a waste container by the printer. So you'll put these in a waste container by the printer. On the double replacement reactions, when you're done with these, you're going to dump it into the garbage can and then clean it out with soap and water and a test tube brush. On these ones right here, you only have 4 that are going to make a solid. So you need to make sure you decide which 4 are actually solids. That's really important because they struggled with that last period. Okay? Yeah, it is. So you should have this pre-lab done. I'm going to talk to you really quickly about this right here. So with this, let me just save that real quick. With this one right here, I want to do this blank 1 with you. Okay, so if you'll get to that point in your lab with you really quickly, we're going to write that together so I don't have to answer it over and over again when you get back to class. So open up your lab to this page right here. Okay, we're doing blank 1. This is the magnesium that I'm going to react with the heat. So when you have the RxN just means reaction. So we're going to write the reaction. We're going to have a magnesium, and it's going to be a solid, and we're going to add something to it. The heat is just a catalyst. What we're adding to it is oxygen from the air. So O2, because it's a Braun-Hifkel and it's a gas, and we're going to put those two together. So magnesium is in the second column. It will have a +2 charge. Oxygen's 2 away from being a noble gas. It'll have a -2 charge. So I'm just going to smash them together over here. MgO. And this will also be a solid. And you're going to be describing that solid when we do the reaction. This is not balanced. You will need to balance it. On the next one, this one's a little bit tricky because it's underneath composition or synthesis. But it looks like it's going to be a double displacement. What actually happens is the NH4OH will decompose to NH3 plus water, and the water is going to be left behind on the Q-tip. And the NH3 is what's going to be the gas. So we're going to have HCl gas reacting with NH3 gas, and we're going to get ammonium chloride. And it's actually a solid. Okay, so we actually have two things going on here. We have a decomposition, and then we have a synthesis. Okay? So did everybody get that down? You'll need to balance them. I'm not balancing them. Some might be balanced already. Okay, but you're going to need to balance it. Okay, we okay to move on? Okay, because I have to erase this because when I scroll up, it doesn't scroll up. Okay, on the next part right here on the decomposition reactions, we're going down to blank 1. So decomposition means whatever I start with. Okay, so you're writing it with me, right? So KCl is going to be a white solid. And we're going to heat it up. So that would be a delta. KClO3. We're going to heat it up. When we heat it up, this decomposition, we are actually going to produce oxygen, gas, O2 as a gas, and we're going to leave behind potassium chloride as a liquid. For the next one, hydrogen peroxide, we're going to start with hydrogen peroxide, and it is a liquid. And we're going to add yeast to it as a catalyst, so we'll put that above the arrow. And we're going to get off oxygen gas and water as a liquid. Again, these are not balanced. You will need to balance them. Okay, I'm just giving you the bones. On the next part, I'm going to do one of them for you. You're going to have to do the other one. So everybody okay for me to move forward? Everybody got this down? Did you write it down? Okay. On this part, on blank 1, we've got 3 blanks. Blank 1, blank 2, blank 3 for one of them, and then blank 4, blank 5, blank 6 for the second one. I'm going to do 1, 2, and 3. You're going to have to do the others. So on 1, 2, and 3, basically, this is my molecular equation, the top one. So I'm taking silver nitrate, I'm adding copper metal to it. I'm going to get copper nitrate and silver. And I've even balanced this one for you. Anytime we have an AQ as a state that it's in, to get to our total ionic, we split it into the ions. So the total ionic is in black here, and we're splitting it into the ions. So 2AgNO3 is made up from 2 Ag pluses plus 2 NO3 minuses. Anything solid, liquid, or gas stays that way and comes straight down. Okay, so copper just comes straight down, and silver just came straight down. To get to from the total ionic to the net ionic, I have to look side to side. What's the same? Remember our spectator ions? So this is a spectator ion, and this is a spectator ion. They're the same on both sides. This is the only spectator ion. In other ones that we've done, we've had more than one spectator ion, but this one, we only have one. The silver can't be a spectator because on one side it has a +1 charge and it's aqueous, and on the other side it's a solid. And copper can't be because it's a solid on one side, on the other side it's a +2 charge and it's aqueous. So to get to our net ionic, we just take out the spectator ions and rewrite it. Okay? So you're going to do that for the other single displacement. So you have to write all 3. So this is the molecular, this is the total ionic in black, and the blue is the net ionic. So 1, 2, and 3.
Okay, so are you going to leave that up on the board?
Yep, I'm going to leave this up on the board. Okay, so now, what did I tell you about the last part of the lab that you needed to be really careful with?
Won't burn yourself.
No. It was with the well plates. Something really important that you needed to know.
Oh, pick which ones are solid.
Yeah, you only have 4 solids, so you need to make sure you identify the 4 solids. Okay, which one are you going to start with when you go back into lab? Single displacement. I will pull you when I get the others set up, and I'll just say, okay, it's time to come. So try and get the single displacement set up before I come back to lab. So that can be running while we're watching the other part. Okay? It is individual. You're doing it on your own. You might have to share a station with somebody, but you're doing your stuff on your own. Okay? You're responsible for your crap. Okay, any questions? Okay, if you are ready and done, then come on up, get a stamp, and you can head back.